Alright, this is a quick video to get you up to speed on part of the lecture that was covered in class on Wednesday night. We're going to start with the first page, types of muscles, and we'll work our way through the first 3 pages. After that, I believe we're back in class to get the notes. So, starting with types of muscles, there are 3 different types. You have skeletal, cardiac, and smooth muscle, and for all purposes, we spend a vast majority of our time on the skeletal muscles just because they far outweigh or outnumber the other 2 types. Skeletal muscle, you have somewhere in the neighborhood of about 640 skeletal muscles in the human body. That number varies. Different people count the muscles differently, and so some people come up with 630, some people come up with 640, some people come up with numbers even higher than that. As long as you know that we're in the range of 630 to 640, that's the widest accepted value of how many muscles are in the human body, you're in good shape. Cardiac muscle is only found in one place in the entire body, and that's the heart. And smooth muscle is found in the organs of the body. So like I said, overall, we spend a majority of our time on the skeletal muscles just because there are so many of them. It's a little bit different with the muscles. We do need to learn some of the major muscles, but we're not going to learn all 600 plus. About 70 or 80 is what we cover through the course of the year. So with the skeletal muscles, in order for it to be classified as a skeletal muscle, it does have to attach to bone, hence the name skeletal muscle. Skeletal muscles, the benefit that you have is that you are able to manipulate the skeletal muscles. They're under voluntary control. So when you want to move, grab onto something, pick something up, those are the muscles that you can tell your brain to send a message to, and how and when you want those muscles to move for you. So that is a benefit that we have with the skeletal muscles. It talks about the muscles being striated, and the best visual example that I can give you for striations is to think of a zebra. Zebras have the light and dark bands, and that allows you to be able to see where one begins and one ends. And essentially that's what striations are. They're not white and black within the muscle tissue. You just have lighter and darker bands. But when you look at it underneath the microscope, you actually can see that banding pattern. And the scientific way to refer to that banding pattern is striations. With the cardiac muscle, as I already mentioned, you only have that in one place in the entire body, and that is going to be in the human heart. And with the human heart, you have striations present, so you can see that banding pattern, but we don't have the voluntary control that we have with the skeletal muscles. So the benefit there is, because your heart has to work 24 hours a day, 7 days a week, you need a backup system, something that's going to control it, something that's going to monitor it, so that you're not constantly having to tell your heart muscle when you want it to work for you. If that were the case, you guys would never be able to sleep, because as soon as you fell asleep and were not telling your heart to beat, obviously it would stop. So benefit on your skeletal muscles, you get to dictate when they work. Benefit on the cardiac muscle is because it constantly has to work. You have a system built into your brain that takes over that control so that you're not having to constantly think about it. Smooth muscle is going to make up your viscera, which is referring to your internal organs. It also is going to be located in the vascular systems of your body, so it's in your blood vessels as well as your lymphatic vessels. And with your vessels, you have an outer layer and an inner layer. The muscle is actually going to be sandwiched in between those other 2 layers of epithelial tissue. And that smooth muscle, again, is something that you don't have to tell it when you want it to work. It's just automatically programmed to work for you, to respond to conditions in and around your body. So in situations where you're cold, that smooth muscle layer in your blood vessels will constrict, pulling the blood vessels away from the surface of the skin, trying to maintain your body heat. So just those things that naturally occur, again, that you don't even have to think about, are going to be the responsibility of that smooth muscle. You sit down to a meal, put food into your stomach, you don't have to tell your stomach to digest that food. That smooth muscle, taken care of by the brain, it's going to tell your stomach to go ahead and go through the process of digesting that food. If you flip over to page 2, the major parts of the muscle, obviously the skeletal muscles all three classifications of muscles are going to be the organ of your muscular system. It's a living tissue, so it does need to have a nerve supply as well as a blood supply in order to allow for muscles to be able to communicate with each other. And the most important connection with the nerves and the muscles is the nerve actually is going to bring the impulse to the muscle to tell it that it needs to contract. So something happens inside your body, close by your body, and starts a stimulus to the nerve. That nerve runs right up to the muscle itself, and it's going to release a hormone to the muscle telling it that it needs to contract. So that connection between the muscle and the nerve is very important, because without that information coming from the nerve, the muscle would never know exactly when it was supposed to contract to carry out movement or some other response in the body. The blood supply to the muscles are very important. Muscles consume a lot of oxygen in order to do the work that they're supposed to do. So by having that blood supply, a very high blood supply to your muscles, it allows for that oxygen to quickly and efficiently be delivered to the muscles so they can continue to do the work that they need to do. Within the muscles, you also have different types of connective tissues that are going to help hold the muscle together. A muscle is designed a lot like a string or a shoelace. You have these individual little fibers or strands, and you pull a collection of those together and wrap them together, and then you take more and more bundles and just layer them, continue to layer them together till you actually get to the entire muscle itself. Again, if you're kind of a visual learner, think of a shoelace and that little plastic thing that you have on the end of the shoelace to keep it from fraying. That's essentially how your muscles are designed. Individual strands, and you just bundle all those little individual strands together so that they can collectively work together to perform a job. The main types of connective tissues that you're going to have, we'll get into the layers here in a second, but you have tendons and ligaments. Tendons are going to be responsible for connecting muscle to bone. Ligaments connect bone to bone. And a lot of times you hear people use those terms in place of each other, but they are very specific. Tendons are going to connect muscle to bone. Ligaments are going to connect bone to bone. Fascia. Fascia is the layer of connective tissue that wraps around the entire muscle itself. So if you think about saran wrap, if you saran wrap something up, that would be the equivalent of the fascia. So if you have a sandwich, you put saran wrap around it, holding all the individual pieces together. That's essentially what the fascia is going to do for the entire muscle. It just wraps around the entire muscle as a whole, holds all the individual parts together so that they can work as one unit and do their job. Tendons, as I already mentioned, these guys are going to arise out of the muscle tissue itself. And when we did the chicken wing dissection, that was one thing that I wanted you guys to recognize, is how that muscle tissue just transitions into that tendon. And you could see it go from that peach color that you associate with the raw chicken and transition into that pearly white color, which is the tendon itself. The last one on there, the aponeuroses. This one is actually a tendon as well, but it's a little bit different type of tendon. It's a very broad, flat sheet, very large in size, where a tendon is going to connect some of the muscle fibers to the bone. An aponeurosis is an entire sheet of tendon that connects large areas together. The two main examples that you guys have are in the picture. You have one that's going to be across the entire scalp, so it runs from the front of the forehead to the back to the occipital location of the skull. And actually, when you guys raise your eyebrows, part of that is a contraction of the occipitalis muscle, which runs across the back of your head. That muscle contracts, it pulls against that aponeurosis, which is connected to the frontalis muscle in the front, raises your eyebrows up. The other location is across the abdominal core. If you guys think about your rib cage stops, and then you don't have another set of bones until you get down to your pelvis, your hips. You need to have protection. You have some pretty important organs in that space. And so to help offer a little bit extra protection as well as stability, we have that sheet of aponeurosis, that large broad tendon, through that abdominal core to help protect your internal organs as well as help hold your core all together. Then turn over to layers of a muscle. On layers of muscle, you have an image there, which I think does a nice job of showing you kind of what I was talking about earlier, how the muscle is actually composed of individual strands. You bundle those strands together, and you just keep repeating that process of bundling individual strands and bundles together until you get the entire muscle all as one. The separation that I want to make on this page is the muscle coverings to the muscle structures. The muscle coverings are actually sheets of connective tissue which are going to help, or membranes that are going to help hold the individual strands together. And they get different names just based on which group of strands they're holding together for you. The second group that you have there, muscle organs, fascicles, myofibrils on down, those are the actual structures or the parts of the muscle. So the top one, these are actually bundling everything together, and the second group is the actual structures that make up the muscle itself. So I'm going to start small and work my way up. So if you look at the picture, you'll notice the filaments. The filaments are actually made up of two different types of proteins known as actin and myosin. Actin is a thin protein, so it appears light in color when you look at it underneath the microscope. Myosin is a thick protein, so when you look at it, it appears dark. And if you go back to page 1, we talked about the striations, that banding pattern, kind of zebra look that you have with your skeletal muscles. That's actually where it comes from, is that actin and myosin. Actin is the thinner protein, so when you look at it, it appears light in color. Myosin being thicker, looks darker, and when you line them up next to each other, it ends up having a banding pattern of light and dark bands. So that's what makes up your filament. When you get a bunch of those filaments together, that is what we know as a myofibril. So it's a collection of those actin and myosin strands all bundled together. When you continue to pull those myofibrils together and bundle them into one unit, that is known as your muscle fiber. Some sources will actually refer to it as a muscle cell. So we start with the filaments, we bundle those together, we get to a myofibril. You bundle the myofibrils together, that gives you your muscle fiber. And then when you take a collection of muscle fibers and put them all together, that's what's known as a fascicle. So it's a group of those muscle fibers all bundled together. And then when you bundle a bunch of fascicles together, that is going to be the entire muscle itself. I know it's complicated, it's probably a lot of terminology that you might not have a huge amount of background with, but kind of think of it, if you've ever braided somebody's hair, you've seen somebody's hair braided. You have the individual strands of hair, you group them into 3 large chunks, and then you weave those 3 pieces together. And you just keep taking the small parts, putting them together until you get the end product of your braid. That's exactly what's happening with our muscle. We just use different terms. So you have your actin and myosin forming the filaments. Filaments come together to make your myofibrils. The myofibrils come together. They will eventually form the muscle fibers. The fibers all group together and they form your fascicles. Fascicles, when you get a bunch of fascicles all collected together, that is your muscle as a whole. Now, we need to take those little fibers and we need to start bundling them together, and that's where your epi, your peri, and your endomysium come together. If you look at the prefixes, they kind of tell you location-wise where they're at. Endo is going to be the innermost layer, peri is sandwiched between, and epi is the outer layer of those 3. Okay. So when you look at the picture and you locate the endomysium, if you follow that arrow down, that is going to be located around your muscle fibers. Then you have the perimysium. The perimysium is going to wrap around the fascicles, and then you have the epimysium. That is actually going to be around the muscle itself. So endomysium, that is around the muscle fibers. The perimysium, that is around the fascicles. And then the epimysium is around all of the fascicles, and it bundles all of them together. Then just to help hold it all together, strengthen it, you have another layer known as the fascia, and that wraps around everything. So it's the outer coating or the outer layer that you would have over the epimysium. So that takes us to the point where everybody came back together as a class. So hopefully you have the notes following that, and I will see you in class on Monday.